Welcome to MRL. This is the second part of the study of solutions of examples of circles, and in the first part we have learnt some of the examples of circles, and now in the second part we will be learning the remaining examples of the exercise of circles chapter of 10th CBSE NCERT textbook. Now example number 8, here we are given a quadrilateral ABCD. ABCD is a quadrilateral which circumscribes a circle with center O. So ABCD is a quadrilateral which circumscribes a circle with center O. And we have to prove now that AB plus CD, the opposite sides of this quadrilateral, is equal to AD plus BC. That means the sum of the two opposite sides are equal to the sum of the two other opposite sides. Now let us prove it. Let us take LHS, that is AB plus CD. Let us take AB plus CD here. So I have taken AB plus CD here. But we find AB is equal to AP plus PB. So I have taken AP plus that is BP, or PB is the same. So AP plus BP. And also we have CD. CD is equal to CR plus DR. Now you know that in this diagram, or here, A is the exterior point to the circle, AP and AS are the tangents to the circle from an exterior point A, and therefore you know that the tangents from an exterior point to a circle are equal. Therefore AP is equal to AS, and so also DR is equal to DS, and so also CR is equal to CQ, and so also BP is equal to BQ. So we will use that property that tangents drawn to a circle from an exterior point are equal. Now replacing AP by AS, because AP and AS are equal, I have replaced AP by AS here. So I have replaced AP by AS, BP by BQ, CR by CQ, DR by DS. So I have replaced them. So we have got AS plus BQ plus CQ plus DS. Now AS is there here, and also we have DS. So AS plus DS, rearranging them, AS plus DS plus BQ plus CQ. But what is AS plus DS? AS plus DS is nothing but AD, and BQ plus CQ is BC. Therefore we have the RHS, that is so therefore we have AD plus BC, and that AD plus BC is nothing but RHS. So that proves it very clearly, that is AB plus CD is equal to AD plus BC, and that is the proof. So but don't forget here that tangents drawn from an exterior point to a circle are equal, and that is the property we have used in proving this relation. Now in the example number 9, we are given XY and X dash Y dash are two parallel lines drawn to a circle with center O. They are parallel. AB is another tangent. Again we have one more tangent AB which touches the circle at point C. So these are the things given to us. Now we have to prove that angle AOB is 90 degrees. So let us understand how it is to be proved. Now if you inspect this diagram, and this point A is exterior point to the circle, AP and AB are the tangents. AP and AB are the tangents. And if the tangents which are drawn from an exterior point are inclined and they have the same angle of inclination, that means angle OAP and OAB are equal, that means angle 1 is equal to angle 2 here. And so also B is an exterior point, and BC, please understand here, BC and BQ are tangents. Okay, BC and BQ are tangents, and angle BOC, for example, we have BC and BQ are tangents, and angle 3 and angle 4 are equal, because the tangents are equally inclined when the tangents are drawn from an exterior point. So this is a very important property here. Angle 1 is equal to angle 2, because the tangents drawn from exterior point are equally inclined, and so also the tangents drawn from point B are also equally inclined, and therefore angle 3 is equal to angle 4. Therefore that's what I have written here. BQ are tangents to a circle from the exterior, so BQ are tangents drawn from the center from the exterior point, therefore the tangents are equally inclined. And also if you observe that AB is the transversal, AB is the transversal, and XY and X dash Y dash are parallel to each other. If XY and X dash Y dash are parallel, AB is the transversal, then the co-interior angles are supplementary. That means angle 1 plus angle 2 plus angle 3 plus angle 4 is 180 degrees. And that means if angle 1 plus angle 2 plus angle 3 plus angle 4 is 180 degrees, that means we have co-interangles. Therefore, the two lines, that means we have got angle 1 plus angle 2 plus angle 3 plus angle 4 is 180 degrees. But we know that angle 1 is equal to angle 2 and angle 3 is equal to angle 4. That means 2 times angle 2 plus 2 times angle 3 is equal to 180 degrees. But angle 2, that means angle 2 plus angle 3 is 90. If angle 2 plus angle 3 is 90, in triangle AOB, if 2 and 3 equal 2 plus 3 is 90, then angle AOB has to be 90 degrees, and that is exactly what I have proved here. So I have shown here angle 2 plus angle 2 plus angle 3 plus angle 3 is 180 degrees, because angle 2 and because they are equal. Therefore we have the two angles, angle 2 plus angle 3 is 180, and because angle 2 plus angle 3 is 180, in the triangle AOB, angle AOB plus angle 2 plus angle 3 is 180, angle AOB plus 90 is 180, angle AOB is equal to 180 minus 90, or angle AOB is equal to 90 degrees. So please go through this example and try to understand, and that is how we can prove it. Now coming to the next example, that is the circle given here with center O. We are given a circle with center O. PA and PB are the tangents to a circle from exterior point P. Now we have to prove that angle APB plus angle BOA is 180 degrees. A very simple proof. Now if you observe very closely, we find that PA is a tangent from exterior point P, PB is a tangent drawn from exterior point P. Now if I join OA and OB, then the angle OAP and OBP are both 90 degrees, because the radius and the tangent at the point of contact are perpendicular to each other. Now PAOB is a quadrilateral. If angle A and angle B are sum of the angle A plus angle B is 180 degrees, but natural angle AOB plus angle APB has to be 180 degrees, because 360 degrees minus 180 degrees is again 180 degrees. So that is exactly what I have done here. So I have taken the quadrilateral AOBP and shown that the sum of angle A angle B is 180. Therefore angle P plus angle AOB also has to be 180, and that is what is the proof first, and we have proved it. So try to remember that. Now coming to the example number 11, to prove that the parallelogram circumscribing a circle is a rhombus. That means we are given a circle with center O, and we have drawn a parallelogram here, that is ABCD is a parallelogram. That means AB is equal to DC and AD is equal to BC. Now we have to prove that ABCD is a rhombus. We have to prove that ABCD is a rhombus. Now in quadrilateral ABCD, AB plus DC, let us take AB plus DC. So I have taken AB plus DC here. What is AB? AQ plus BQ. AQ plus BQ, because A is exterior point and AP and AQ are the tangent drawn from exterior point to a circle. Therefore AP is equal to AQ. Same way BQ is equal to BR. Same way CR is equal to CS. Same way DS is equal to DP. And substituting these values, AP, so I have got AB is equal to AQ plus BQ, and DC is equal to, that is CS plus DS. Okay, CS plus DS. No, but DS, please understand here, AQ is equal to AP and DS is equal to DP. So I have replaced it. AP plus BR. BQ is BR. BQ is definitely BR. Okay, correct. And CS is CR. Okay, I have replaced CS by CR, and also I have replaced DS by DP. Now rearranging them, we get AP plus DP plus BR plus CR. AP plus DP is nothing but AD. So I got AD here. BR plus CR is nothing but BC. That means what I have done here is that I have shown that AB and DC are equal. AB and DC are equal, and so also AB plus DC is equal, and AD plus, please understand here, AB plus DC, I have shown AB plus DC is equal to AD plus BC. Now AB and AB are equal. See, DC is equal to AB because they are opposite sides of parallelogram. Therefore I can replace DC by AB, and so also AD plus BC are equal. Therefore I can replace BC by AD. That means 2 times AB is equal to 2 times AD, or 2AB is equal to 2AD. 2 will cancel. I have shown that AB is equal to AD, and you know that in a parallelogram, if a pair of adjacent sides are equal, then it becomes a rhombus. This is the property of a parallelogram, because rhombus is a special parallelogram, and in a parallelogram, if a pair of adjacent sides become equal, then that becomes a rhombus, and that is what is the property we have used here, and we have shown it, that we have shown very clearly that AD and AB are equal here, and that is what is the proof of this particular example. Now the example number 12, we are given a triangle ABC. ABC is a triangle circumscribing a circle. So we have got an in circle here. We have an in circle of radius 4 centimeters. D is a point of contact on the point of contact dividing BC into CD and BD. CD is of 6 centimeters, BD is 8 centimeters. Now we have to find the length of the sides AB and AC of this triangle ABC. That means it is very clear. We are given one side, that is 8 plus 6 is 14 centimeters. Now we have to find AC and AB. So let us see how to do that. Now in the figure, C is the exterior point. C is the exterior point of this particular, C is the exterior point, and that is that means tangents is drawn to the circle. So CE and CD are equal tangents because the tangents drawn from an exterior point are equal, and so also B is the exterior point, therefore BF is equal to BD. So also A is the exterior point, therefore A is equal to AF, because the tangent drawn to a circle from an exterior point are equal. Now having understood that, now we have CD is equal to 6 centimeters, so also CE is 6 centimeters. We have BD is equal to 8 centimeters given to us, therefore BF is also 8 centimeters. But we are not knowing AF and AE, so let us assume them to be X and X centimeters. So now we have to find out this value of X. See, the value of X, the X is unknown here to us. We have to find the value of X. To find out AC, I should get X to find out length AC, and also I should get X to find the length of AB. But when one unknown is there, now we need one equation to get that one unknown. So we have to frame an equation to get one unknown. Let us see how to frame this equation from the given information. Now to find the value of X, we have to find the equation, and we are given the radius of the circle is how much? 4 centimeters. Now let us go for a construction. Join OA, OC and OB. So we get three triangles here: triangle AOC, triangle BOC and triangle AOB. So three triangles are there. So let us find the area of these three triangles. Now we can find the area of the triangles by multiplying half base into height. So half into base is BC here, half into 14, half into area of triangle AOB is half into base is half into 14 and into 4 because height is 4. So also area of triangle AOB will be half into base will be 8 plus x centimeter into height is 4, and so also triangle AOB will be half into 6 plus x into 4, that is the area, all the three areas we are going to add. So by simplification we get 2 to the 4, 14 to the 28, and here 2 to the 4 8 plus x into 2, and here 2 to the 4 6 plus x into 2. So simplifying further, 28 plus 16, 8 to the 16 plus 2x plus 6 to the 12 plus 2x. So we got 28 plus 28 plus 4x, and further simplification we get 56 plus 4x, and that is the area of triangle ABC. So that means by finding out the area of the three small triangles here, I have found out the area of the triangle ABC, and the area of the triangle ABC is 56 plus 4x centimeters square, and let us call this as equation 1. Now also we can find out the area of the full triangle, that is the original triangle ABC, by using Heron's formula. Using the Heron's formula, that is S minus A, S minus B, S minus A square root of S minus A, S minus B, S minus C, where S is equal to A plus B plus C divided by 2. Now we know the value of A is 14 centimeters, value of B is x plus 8 centimeters, C is x plus 6 centimeters. When we add and simplify, we get S is equal to 14 plus x, and putting these values of S, A, B and C in Heron's formula. So we have A is 14 centimeters, B is x plus 8 centimeters, C is x plus 6 centimeters, and S is 14 plus x, S is 14 plus x centimeters. Now substituting the values here, area of triangle ABC will be equal to square root of S is 14 plus x, and this will be 14 plus x minus 14, S minus A, and S minus A will be 14 plus x minus in the bracket x plus 8, and again we have got 14 plus x minus in the bracket x plus 6. Now again further simplifying, we get 14 plus x here, 14 gets cancelled into x, and here it will be 14 plus x minus 8, and here 14 we get 14 plus x minus x plus 6, plus x minus x cancels, plus x minus x cancels here, so we get 14 plus x into x. 14 minus 8 is 6, and we have here that is 14 minus 8 is 6, and we have 14 minus 6 is 8, so we got 6 and 8 here. Now 8 6 are 48, again x in the bracket 14 plus x, again we are taking the square root. We have got x in the bracket 14 plus x, 16 3 is 48, and square root of 16 before taking the 4 outside we get square root of x in the bracket 14 plus x into 3, and that is equation number 2. So this is centimeter square, that is the area of the same triangle ABC. So we have got two equations. One equation for area of triangle ABC is 56 plus 4x centimeter square, and the second equation is 4 root of x 14 plus x into root 3, that is the second equation. I can equate the RHS of 1 and 2. By equating RHS of 1 and 2 we get 56 plus 4x is equal to 4 times root of 3x plus root of 3x in the bracket 14 plus x. Now what I will do is, now I can take common 4 in this, so 4 in the bracket 14 plus x, 4 gets cancelled, so I get 14 plus x is equal to root of 3x in the bracket 14 plus x. Now I can square on both the sides, so I will do that. So I will be squaring on both the sides now here, because I want to eliminate the square root in this case. So 14 plus x whole to square is equal to the square root is eliminated. I get 3x in the bracket 14 plus x. But 14 plus x I can cancel with 14 plus x here, but otherwise I have gone for further. I can easily cancel, but I didn't do that. I have gone for the squaring of this. So 14 square is 196, and x square plus 28x by applying a plus b whole to square form and opening this, I'll get 14 3 is 42x, and we get 3x square. Now if I rearrange them in write in standard form, I get 3x square minus x square plus 42x minus 28x, that minus 196 is equal to 0, or 2x square plus 14x minus 196 equal to 0, x square plus 7x minus 98 equal to 0, or by middle term splitting method I can go for x in the bracket x plus 7, that is x square plus 14x minus 7x minus 98 equal to 0, or taking common x in the bracket x plus 7 minus 7 in the bracket x plus 7 equal to 0, or x plus 7 into x minus 7 equal to 0, or x plus 7 equal to 0, or x minus 7 equal to 0, or x is equal to minus 7, or x is equal to 7. Neglecting the negative value, taking the positive value, we get x is equal to 7. Since we have got x is equal to 7 but natural, the length, the side AB of the triangle will be x plus 8, and that is 15 centimeters, and that is 7 plus 8, that is 15 centimeters, and the side length AC is equal to x plus 6, and that is 7 plus 6, and that is 13 centimeters. So that is a lengthy calculation, definitely a question asked many a times. It is a question of almost 4 marks for you. So please practice this, learn it, and try to remember. Okay, now coming to the next example, we are given a quadrilateral circumscribing a circle. So a quadrilateral ABCD is given, which is circumscribing the circle with center O. We have to prove that the opposite sides of the quadrilateral subtend supplementary angles at the center of the circle. That means we have to prove the opposite sides. Let us take the opposite side, means I can take AD and BC. Now AD and BC, if I join OD and OA and OC and OB, that means we have to prove that the angle AOD plus angle BOC is 180 degrees. So let us see how to do that. Now for that I will first mark the midpoints of the sides of the quadrilateral, that is not midpoint, we will draw the perpendicular from the center to the quadrilateral sides, that is OP is perpendicular to AB, and OQ is perpendicular to BC, and OR is perpendicular to CD, and OS is perpendicular to AD. Now having drawn that, now A is the exterior point, B is the exterior point, C is the exterior point, D is the exterior point, and therefore from the exterior point AP and AS are the tangents, they are equal, and also from the exterior point B, BP and BQ are the tangents. From the exterior point C, CR and CQ are the tangents. From the exterior point D, DR and DS are the tangents. And we know that the tangents subtend equal angles at the center. Therefore, angles subtended by the tangents AP and AS at the center are AOS and AOP. Both are equal, that is x and x. Same way, I have taken these two angles subtended by the tangents BP and BQ as YY, and ZZ by CQ and CR, and WW by DR and DS. So that means in all I have the XX angles, YY angle, ZZ angle, W. That means all these angles are subtended by the tangents from the exterior point, but this angle at the center is 360 degrees. The angle at the center is 360 degrees. That means x plus y plus z plus w is 360 degrees. That means 2x plus 2y plus 2z plus 2w is equal to 360, or x plus y plus z plus w is equal to 180 degrees. And x plus w, if I just rearrange them, I get x plus w plus y plus z is equal to 180. Now what is x plus w here? X plus w is angle AOD, and y plus and y plus z is BOC. That means I have got angle AOD plus angle BOC is equal to 180 degrees. That proves that the opposite sides of a quadrilateral circumscribing a circle subtend supplementary angles at the center. If AD and BC are subtending 180, so also CD and AB are also subtending 180 degrees at the center, and that is how we can make use of the properties of the tangent drawn to a circle from an exterior point to prove these theorems, or to prove these examples given to us. So that is what is the study of the what you call solutions of various different examples of the exercise of circles of 10th standard CBSE textbook. Okay, learn them and note down all these examples in a book, understand them, practice them, and okay, then only you'll be able to solve them. But again, let me suggest, please remember or go through the basics of circles, basics of tangents, then only you'll be able to understand the solutions of these examples. Okay, thank you.